Iran stuff. Today's episode is share your spare unused CPU cycles to help various organizations in their research. Now, some people, I leave my computers on 24/7 for this purpose. I'm not one where I shut them down at night and start them back up again the next morning. I leave them running 24/7. And I have multiple computers. And a ways back, probably, I don't know, could be as far back as 2000 or 2005, I became aware there was an organization out of University in California where they were taking Arecibo radio telescope data and dividing it into chunks and sending it out so that you could, as a home user, you could use all of the downtime, such as screensaver time. And if you're familiar with a screensaver on a CPU on a computer, when it's not doing anything else, it will come up and display something on the screen. And the idea was at that time that you could burn a screen image into the old CRT type displays, and that would keep from burning an image. But the screensaver concept is still stuck. It's still available in all Windows versions. And that's where I, instead of doing a screensaver, I actually process data from various servers from the United States and maybe even around the world. I know it's around the world because I participate in the Large Hadron Collider research. So anyway, I signed up for this, and at that time it was processing Arecibo radio telescope data, and it was looking for any sorts of patterns, some sort of pattern of signals coming out of the universe, looking in all directions, around the frequency of water molecules, the vibrational frequency of water molecules. Thinking that it would be like a universal water hole, and that if anybody was water-based or had water as part of their living or life requirements, they may think of that as a good place to send out signals to other water-based life forms. So that's what this whole project was about, and obviously tons and tons and tons of radio observatory data collected. So it would be hours and hours and hours and hours looking at one particular region of the sky and collecting a significant number of background noise. And the idea was to take that background noise and try to run it through enough times to see if you could detect some sort of pattern. It may be a pattern of a long duration, and that you only got a spike or a digit or a Morse code beep every 5 minutes, or maybe it was much faster than that. But some sort of pattern, i.e. maybe a message, maybe a beacon, maybe something that stood out from all of the background noise in the universe. And there's a lot of background noise. Lots of things emit various frequencies in the universe. So anyway, that's how it all got started. And I did that. My machines ran 24/7 processing Arecibo radio telescope data for years and years and years. And finally, the Arecibo radio telescope was in fact damaged and not repairable during a hurricane. And but the concept of using user PCs to process some of that data stuck, and it makes sense in a lot of different ways. And I'll give you an example. Anything that has large amounts of data, let's take weather for instance. At one time, the only real collection points for weather data was airports, and they're sprinkled pretty far apart, and you cannot get a very good, accurate prediction based on very few data points. and weather is something that can be very localized. So in this particular case, they can divide up that data, send it out, and do some preliminary processing on it, like strip out something, things they're not really interested in knowing about, or cataloging, or whatever you want, and take the pieces, come back from the user, and assemble it again, and perhaps do another level, higher level of looking all that data and stripping data out again, or seeing what patterns they're developing, pressure bars, diagrams. For weather is a good example. Another is image processing. An image can be broken down into sections, just as you know, like pixel base, and to determine if maybe there's an edge in this particular piece of segment of the overall picture. I'll process 5,000 pixel by 5,000 pixel section of that, and you can divide up an image into chunks like that, send them out to users. Their personal computer could crank that section and perform some mathematical function on it, and then return the results back to the server. And this has taken off, and there are various research institutes that have programs that are now using home computer spare CPU cycles to do research, and it makes a lot of sense. A supercomputer, the way it is defined these days, is the number of CPU units it has. At one time, a supercomputer may have had 2, 3, or 4 CPUs, and programs were fed pieces to each one of the 3. That's an old, outdated concept. You can now build a computer that has 5,000 different CPUs in it, or 10,000, and they operate the same way I'm talking about with a computer at home. Each one does a little section of the problem. It's really beneficial for programs with very, very large data sets where you need to do some sort of repetitive numerical calculation on all of it, but you can break it into chunks so each one can be done quickly and parallel with others, and that's the whole point. Supercomputers are now parallel computers in that they have CPUs, lots and lots of CPUs, and running in parallel, and data is exchanged in and out, and small calculations or some sort of calculation is done on it that has stored. Maybe another large program looks at it at that point and detects, hey, over in this region of the total, there's something really of interest. So we'll focus on that region. We divide it up into sections again. We send it back out to all of our microprocessors. We have 10,000 in our supercomputer, and they process it and so on. Same thing, same idea, works the same way with your CPU at home. You're one of the CPUs that's sitting on a vast network via the internet, and there could be millions of home users who are contributing to a particular research project. Now, I contribute to multiple research projects, of which one is looking at cancer tissues and marking the genetic codes of it to get a database of what genetic cancers look like at a genetic level, and then also looking to see what a regular cell, why, where, when, and how does a regular cell mutate into one of these mapped cancer genetic markers of a particular type of cancer. So that is a very good use for multiple parallel processing, because you can rotate a single cancer genome around, and you can try moving this or that, or adding this or that, or clipping this or that, to see what impact it may have on it, the same way with a live cell. I'm also participating in asteroid.home that looks at the asteroids in our local vicinity that's within the solar system or out, and attempts to develop trajectories That's the whole purpose of that. And again, you have a large data set, and you're looking for tracking information. A blip shows up, but you have to watch it for some period of time to see if it's actually has some sort of predictable track, and I participate in that. Large Hadron Collider in Switzerland. That's looking at particle physics. Same idea, massive amounts of data, and you can do some preliminary processes on it to eliminate or find areas or regions of interest that need further exploration. And that all can be done on your computer at home. If it's running 24/7, or even if it's not, anytime, like if you turn it on during the day and you're only doing email on it, you only check email 2 times a day. For hours and hours, that computer is sitting there doing nothing but waiting for a keyboard entry or a mouse to be moved. All that CPU that's sitting in there with all of its memory and however how fast it is can be used to be doing real research in various fields and domains, from medicine to astronomy to particle physics to number theory. I participate in several that play with number theory, and I'm not sure I understand the full extent of that again, but I do understand it's a large data set, and they're trying something, and they've divided it up into sections. I do a little piece, thousands or millions of other people do a little piece. It gets returned to them, they then do another whatever they do to it, and may come up with a smaller data set of more interest. That's divided up and sent out again and processed again by you and me. So I think it's a good thing. Yeah, 24/7, just some electrical power use, but probably less than running a 60 or 100 watt light bulb all year long. So I will eat that cost to help participate in various research projects. That's enough of the intro to this. What I'm going to do is I'm going to take a video camera and take it to one of the PCs I have, because it only works, this whole program only works when there's no other process running on your PC. It's basically sitting there idling. Okay, and I'm going to videotape the screen of that to show you what tasks that are running on that, and it actually has some little visual display that you can see. The main program that supports all this is called Boinc, B-O-I-N-C. You can find it on the web. You can download the Boinc Manager to your computer. You basically set it up. It runs at any time that the screensaver that you define, like, you know, if I haven't used a computer for 3 minutes, start the screensaver. That will then start the Boinc application, and if you have multiple projects like I do, you can set how long each one project runs and the spare cycles that you're providing it. Okay, so Boinc is the main website that you want to look to, and then once you have that downloaded, you can look through a large number of applications that are available to run on your computer. One of them that is currently running on one of my computers has to do with mapping rain in Africa, and the idea is to get a much better handle on rain history in various areas of Africa, so that they could improve their agricultural methodologies based on predicted rain patterns. And again, large amounts of data being collected, has to be slimmed down, has to be, you know, are there patterns here or are there not? That sort of, they're trying to extract information out of a very large data set. And that's true in a lot of different computer applications. So this is the intro to it. I will now go videotape my laptop that is processing data, and you can see what it generally looks like and when it switches between tasks. This is Uncle Ron stuff. This is about sharing your CPU cycles for a good cause. And today is the, I think it's the 6th of August, 2025. Okay, here's a shot of my laptop that I have in the garage, and this is currently
one of the tasks that I'm using via Boca, B-O-I-N-C. And if I can hold it steady enough, you can see this is a screensaver. Actually, it's processing. And I don't know which one this is. This could be asteroid detection and tracking. But it will move around, and it's interesting in itself. But if I watch for a while, you'll see that it will stop that particular task and shows the progress of other tasks that are running on this particular laptop. Now I have, let's see, I have one, two, three, four computers running Boca. So they're all processing research data of some kind or another. And I don't think I have the exact same research project on all of them. Some of them are rainforest, some of them are asteroids, some of them are medical research, some of them are number theory, some of them are whatever. There's a wide selection of scientific fields or disciplines that use this sort of parallel processing to help in their research. They maybe can't afford a supercomputer, and the internet, with users like you and me and millions others, basically form a huge supercomputer, which allows them to deal with massive amounts of data. And anyway, I'm just spending time waiting for this to eventually click over. It will do enough of this processing, and it will switch the screen, and you'll be able to see it. So just a few seconds more. If you were to move the mouse or to hit a key on the keyboard, this would all disappear and your computer would be back for your use. This is just using spare CPU cycles. Otherwise, the CPU is just sitting there. It's doing things. Windows is always doing something. If nothing else, it's tracking what it isn't doing. Here we go. Now it's got to change over, and this is no running task. In this particular case, says that the processor use got so high, it suspended all tasks, and that's some limit you can put on. And when you define it, a whole task issue. How long, how much time do you want to give each task? How much time do you want free? How much disk space do you want to use? So on and so on. And here are, if I can get close enough that you can see them, here's running tasks. There's SR Base, Einstein at Home. Boca is the platform. Here it says I'm running Einstein at Home. The total credits, the average credit, my user login name. And this is with the Einstein physics. Everything is coming out of an EDU by and large. Here, Einstein, a number fields, home, SR base, and what was back at the time. It's all showing. Here's the Large Hadron Collider. I'm doing some processing for that. Let's see what else comes up. Okay. Gamma ray pulsar research. Looking at data here, looking at data that's looking for pulsars in the universe. And again, they got a large data set, and they're looking for a repetitive sort of signature for what they know to be a pulsar, so they're looking for those. Number of fields, SR base. It'll eventually flip over to the other tasks that are running here. I don't think this is all of them. Oh, it went back to it's processing this again because it didn't complete the segment that was given to it. And way I allocate time it gets its share again. So that's the whole idea. That's the whole idea of here is this computer. Now I'm going to take and wiggle the mouse and you can see what will happen. I'm back to my regular screen. All that processing has now stopped and will not go again until this computer sets idle for 3 minutes, 5 minutes. I don't know what I particularly said on it, but you can use your computer now and it has no impact on performance of the computer. All those tasks are there. Some of them may be loaded into memory. You can also specify whether you want that to happen, keep a task in memory. If you're short on memory, then you can set it so it does not use that memory while the task is not running. Anyway, that's the idea. Hopefully, as you'll think about it, if you run your computer 24/7 anyway, why not let it contribute to a research of some type? This is not spam. This is not trickery. This is not hacking of any kind. These are all university type or companies doing research on a valid medical or other um, uh, interest of study of interest, and I think it's worthwhile. You contribute to that. I don't think there's any reward in any kind of form for doing it. You're not going to get $1 million. You're not. You may get a thank you from them periodically, which I do, but other than that, there's no real benefit to you other than you're just doing your little part to make things maybe better in the future by sharing the computer you own that's sitting there just idling away, doing little or nothing of value for anybody. This is Uncle Ron's stuff. I'm not going to add an end to it. This is going to be the end of the video. I suggest you look into it. BOINC is where you start. That will give you the platform that everything, then you can pick projects you wish to add and process, and it's not a difficult setup, and you can obviously play with all the parameters of how long each project gets, whether you want to keep a project in memory when it gets suspended, so on and so on and so on. Uncle Ron stuff, I hope you consider it. That's all for this one.